Jai Hind. The topic for today's discussion is TCP for wireless networks. This topic is particularly covered in Unit 2 for the subject mobile computing. First of all, we will discuss the TCP IP model, 5-layer basically. We are having in a TCP IP model, you are aware that the bottom layer is the physical layer. Above that, we are having a data link layer, then internet layer, transport layer, and the application layer. On the physical layer, at the physical layer, these are the protocols, that is Ethernet, ISDN, we are having WiMAX and so on. On the DLL, we are having HDLC, FDDI, frame relay, etc. On the internet layer, we are having IP version 4 and 6, ICMP, ARP, and so on. At the transport layer, we are having TCP, UDP. At the application layer, the protocols are Telnet, then we are having HTTP, FTP, Gopher, and so on. So these are the various protocols which are operating at various layers of the TCP/IP model. This TCP model is basically for the wired environment. So at the transport layer, where the TCP protocol is existing, it is existing at the layer 4, that is a transport layer. It sits between the application and the network layer. At the network layer, it provides the basic addressing and routing service. No guarantee of delivery or ordering or duplicate removal is there. At the transport layer, the protocols, for example, UDP and TCP, they provide other basic services also, for example, like delivery to process rather than host. For this, we require application multiplexing and demultiplexing, and how the delivery to the process is being done with the help of port numbers. For transmission, the transport layer protocol must keep track of what data comes from each application, then combine this data into a single flow of data to send it to other layers. Splitting the data and tunneling it to appropriate recipient processes. It is responsible for dividing potentially large number of application data into smaller segments or the blocks for transmission. Error checking is also being done, and the error detection fields, that is or checksum, they are present in the headers. TCP, basically, what are the properties or the characteristics of the TCP protocol? It is a connection oriented protocol, reliable, full duplex in nature, provide buffering, and byte stream is there. What the meaning of connection oriented? Connection oriented means that a virtual connection is established before any user data is transferred. That is, when the sender is trying to send something to the receiver, then a link is to be established between sender to receiving end before the actual transmission begins. If the connection cannot be established, then the user program, that is a sender, is notified. And if there is some, for suppose the connection has been established, but later on some problem comes in the connection, then again there should be a mechanism that each sender and receiver should be notified. A notification should be sent that the link has been disrupted. It is reliable in nature. It means that every transmission of data is acknowledged by the receiver. That is, when the receiver receives the data, then it sends the acknowledgement to the sender. If the sender does not receive acknowledgement within a specified amount of time, then the sender retransmits the data. It assumes that the data has been lost. Byte stream. Here the stream means that the connection is treated as a stream of bytes. The user application does not need to package the data in individual datagrams. And you people are aware that you have studied the datagrams in the UDP protocol. Buffering. TCP is responsible for buffering the data and determining when it is time to send a datagram. It is possible for an application to tell TCP to send the data it has buffered without waiting for a buffer to fill up. Full duplex. TCP provides transfer in both directions. To the application program, these appear as two unrelated data stream. That is, when the sender is sending some data to the receiving, then it means it is a one network flow in the forward direction. Similarly, when the receiver is sending something to the sender, then this is a backward flow and it is considered as another flow over the network. Although TCP can piggyback control and data communication by providing control information such as acknowledgement packet, that is ACK, along with user data. Now, what is the motivation that we need to study TCP separately for the wireless environment? TCP protocol, typically it is being designed for fixed network. So, here it is basically designed for the fixed or wired networks. Data transmission takes place using network adapters, fiber optics, copper wires, special hardware, routers, etc. This hardware typically works without introducing transmission error. TCP congestion control, packet lost in fixed network, typically due to temporary overload situation. We are aware that whenever a packet loss is being done, then what's the reason, exact reason behind the loss? Routers discard the packets as soon as the buffers are full. TCP recognizes congestion only indirectly via missing acknowledgements. That is, if the sender doesn't receive acknowledgement for a long time, then it assumes that the network there is a lot of congestion or the traffic in the network. Retransmissions unwise. They would only contribute to the congestion and make it even more worse. To do congestion, TCP begin slow start algorithm, that is ordinary TCP, that is the TCP protocol for the wired environment. Whenever it found a congestion in the network, then it will go for the slow start algorithm. What the slow start algorithm says? It says sender always calculate a congestion window for a receiver. Start with a congestion window. Initially, it starts with the segment of size 1. If the acknowledgement arrives, then it will double the packets. That is, now the congestion window becomes 2. When it receives the acknowledgement for these 2 packets, then what it will do, it will further increase for the next cycle, it will increase the congestion window to 4 and so on. So this is growth of the packet in terms of exponential. It stops at the congestion window threshold. That is, some threshold needs to be decided at what congestion window size. Now you are not further increasing the value. Missing acknowledgement causes the reduction in the congestion window to by 1/2 of the current congestion window. For example, if my congestion window is 4 and TCP founds that now it is not receiving the acknowledgement. Now what it will assume that there is a congestion in the network, and for the next cycle from 4 it will becomes 2. Now the congestion window now starts again with 1 segment. TCP fast retransmit recovery protocol. This is another TCP protocol. What we do here, TCP sends an acknowledgement only after receiving a packet. If a sender does not receive acknowledgements for the same, the sender can now retransmit the packet before time expires. It is called fast retransmission. Also, the receiver got all the packets up to the gap and is actually receiving the packets. Therefore, packet loss is not due to congestion and continue with the current congestion window. That is, fast recovery can be done in this case. In the following simplified analysis, we do consider neither fast transmit nor fast recovery. Now, what are the influences of mobility on TCP? While a slow start is one of the most useful mechanism in fixed, it won't work with the same efficiency in the wireless environment. TCP assumes congestion if the packets are dropped. Typically, this assumptions in the wireless network won't work. Here we often have the packet loss due to various transmission errors. Furthermore, mobility itself can cause packet loss. Example, a mobile node is roaming, then it is changing its access point from one foreign agent to another foreign agent. Then in this case, what is happening? The packets are still under the transition, so they will reach to the old access point, which is the wrong one. And forwarding is not possible in the case of a highly mobile node. The performance of an unchained TCP degrades severely. That is, if you adopt TCP without changing its behavior in the wireless, then the performance of the network would degrade. However, TCP cannot be chained fundamentally due to large phase of installation in the fixed network. TCP for mobility has to remain compatible, as we have seen that when a sender is receiving the data, a sender is sending the data to a receiving end, then in that case, our network may be divided into two. One is wireless part, another part is wired part. In the wired part, we are following the normal TCP protocol, but for the wireless, we need a variation of this TCP protocol, and both these that is the existing TCP and the variation which you have adopted, TCP, they should be compatible with one another. So these are the some TCP improvements which has been proposed in the wireless environment. The first one is indirect, which is also known by the name I-TCP. Another one is a snooping TCP. Then we are having mobile TCP, that is M-TCP. Another modification is known by the name fast transmit or fast recovery. Transmission timeout freezing is another option, selective retransmission. And the last one is a transaction-oriented TCP, which is also known by the name T-TCP. So we are going to discuss all these improvements on the classical TCP one by one. So let's start with the first one, that is the indirect TCP. Here the TCP, we are aware that the TCP, that is a classical TCP, it performs poorly with the wireless link. So TCP within the fixed network cannot be changed. Due to above problems, I-TCP is developed. Here what we need to do, I-TCP segments a TCP connection into two parts, one for the fixed part and another one for the wireless part. And how the distinction two parts had been distinguished with the help of the access point, that is our foreign agent. It is used as a segmentation point. The standard TCP is used into the fixed part, whereas the modified version is used for the wireless part. Here FA, that is a foreign agent, controls the mobility of the MH, that is a mobile node which is present in the wireless environment, and also hand over the connection to the next FA. The CN, that is a computer node. This is your receiver. In the fixed network does not notice the wireless link. FA act as a proxy and relay the data in both the directions. So how the things being done? Here we are having the wired environment. Here standard TCP would work. Here we are having the modification of the wireless TCP. And this foreign agent, it is acting as a proxy between the for the wired network. So if CN sends a packet, the FA acknowledges this packet and forward this packet to the mobile node. That is, if it is sending something to proxy, that is a foreign agent. Now the acknowledgement packet, that is the ACK packet, would be sent by this foreign agent and not by the mobile agent. Now, if a packet is lost in the wireless due to some error, CN will not notice it, but FA will retransmit to maintain the reliable data transport. Now, what will happen? It is sending the acknowledgement to the to this CN node. This is your CN and this is my MH and this is my FA. Now, it will forward the packet to the MH. MH will in turn give the ACK. This ACK is being received by the mobile agent. So once the mobile agent, foreign agent, it receives the ACK, it assumes that the packet has been delivered to the MH. But if this FA fails to receive the ACK packet from the mobile host, then it will assume that there is a packet loss in the wireless environment and it will retransmit the packet, that is the packet which has been sent by the CN. Now it becomes a correspondent node for the mobile host. It will retransmit the data packet to the mobile host. Now, what happens if the MN sends a packet? Then again, same thing would happen. ACK would be sent by this proxy. If MN sends a packet, FA acknowledge this packet and forward it to corresponding your computer node. Packet loss in wired network is again handled by the foreign agent. This is actually what is happening. If you look at the figure, we are having mobile node, we are having FA and CA. CA and MN is sending the packet to FA, and this FA is responsible for sending the ACK packet to the mobile node, and it is forwarding this packet to CN. CN is sending to ACK to the FA, and if in this particular connection, particular flow, what is happening? Your CN node is sending the packet to the MN. FA will receive the packet. It will send ACK back to the computer your computer node, and here the packet is being forwarded to the MH, and in turn MN or MH it will send the ACK packet to the FA. And how the migration is being handled in I-TCP, that is when this is fixed, but mobile host, it has been moved from here to here. So, and that is we have changed the access point. Now in this case, what is happening? Now the mobile node, it will send the data. This is your access point 1. Earlier it is communicating with this particular mobile, for example, it is in this particular region. Then in that case, it will forward the packet to FA. Now FA is aware that the host has been moved to, is now being connected with another access point. Now this will forward the packet to this access point, and this access point now becomes the foreign agent for this communication. Now the further communication is being done between CN, FA2 and MH. So what are the advantages of I-TCP? No changes in the fixed and network is required, and no changes for the host. So TCP protocol, your classical TCP protocol would work there. Transmission errors on the wireless link, it will not propagate to the fixed network. Simple to control. Mobile TCP is used only for one hop between, example, a foreign agent and the mobile host. Therefore, a very fast retransmission of packet is possible, but it is having its own disadvantages also. One of the drawback of I-TCP is the segmentation of the single TCP connection into two TCP connection, and this loses its original end-to-end TCP semantics. And acknowledgement to a sender does not any longer mean that the packet has been successfully delivered to the receiver, to the receiving end. Another variation is snooping TCP. Here, what is happening? FA buffers all the packets sent to MN and snoops the packet flow in both the direction to recognize the acknowledgement. That is now what the FA foreign agent is doing. It is snooping. It is reading the your packet flow in both the direction. To transmit, to remain transparent, FA does not acknowledge the source until it gets the acknowledgement from the destination. That is, it is not immediately sending the ACK packet to the sender. What it will doing? It is first listening the packet, and it is determining whether the ACK has been received or not from the receiver end. Lost packet on the wireless link will be retransmitted immediately by the mobile host or foreign agent respectively, so-called local retransmission. That is what is happening here. End-to-end TCP connection has been maintained. Here what is happening? The foreign agent, it is basically buffering the data and it is snooping for ACK. And here the local retransmission is being done at the FA end only. It is, this part is not, retransmission is not being done by the correspondent host or correspondent node. This is basically what is happening in CN when the communication is from CN to MN, end-to-end, how the end-to-end TCP connection has been maintained. Here we are having FA, CN and MN. CN is sending the packet to FA. FA is forwarding this packet to MN. MN is sending ACK to FA will receive. It will only see whether there is ACK or not, and it will further redirect ACK to the CN. Now, what is happening when the packet is lost? FA to MN. Now, what is happening here? Packet is lost, so ACK won't be received by the FA. So it will assume that there is a packet loss, and now it will do the retransmission. And this retransmission, it is a local retransmission. Once the MN node, it receives the packet, it sends the ACK to the FA. Now FA comes to know that the packet has been successfully delivered to the MN, and it will delete that particular packet from its buffer. Now, when the communication is from mobile node to CN, now in this, what is happening here? Now the wireless connection is here, and it is your wired connection. Here we are sending the packet. It is sending the acknowledgement which is being received by the MN. FA is only listening to this packet. Now, what happens if the packet is being lost in the transmission, wireless transmission? So this gap is being detected by the FA, and it will, what will happen now? It is buffering the data, so it will send that particular packet to the correspondent node, and also it will send a NACAK packet to the MN. Now MN come to know that particular packet has not been received by the CN, and here it will resend the packet. That particular packet which has been lost, it is resent by the MN. Now this packet reach to the CN, and it will send the acknowledgement to the mobile node, and the mobile node comes to know that okay, this particular packet has been received by the correspondent node. So in the case of the snooping TCP, data transferred to the mobile host, that is FA to MH. FA buffers the data until it receives ACK of the MH, and FA detects the packet loss via duplicated ACKs or timeout. Fast retransmission is possible, transparent for the fixed network. Data transfer in the case of data transfer from MH to FA, FA detects the packet loss on the wireless link via sequence numbers. FA answers directly with NAC, that is not acknowledgement packet, to the MH. MH can now retransmit the data with only a very short delay. And what is the advantage? It maintains the end-to-end semantics of the classical TCP in both wireless and the wired environment. Another variation is the mobile TCP. Here the spatial handling of lengthy or frequent disconnection is being handled in the case of the mobile TCP. M-TCP, it splits, as we have seen in indirect TCP. It works accordingly to this. Unmodified TCP works in the fixed network. Here your correspondent node is known by the name supervisory host. Now we have optimized TCP SH to MH. SH is responsible for exchanging the data between both the parts, which is similar to I-TCP. SH does not perform cache or retransmission of the data via SH. If packet is lost in the wireless link, the sender retransmitted. Supervisory host, no caching, no retransmission is being done by supervisory host, monitors all the packets. If disconnection detected, then the sender window size is reduced to 0. Sender automatically goes into the persistent mode, that is no change mode. SH reopen the window to the old value, that is when SH congestion window is again reopened, it will reopen at the previous value. As soon as the connection is live, the sender can continue sending at full speed. What are the advantages? Maintain the TCP end-to-end semantics. The SH does not send any acknowledgement by itself. It only forwards the acknowledgement. Similar to the scene which we have discussed in the snooping TCP. It supports the disconnection. If MH got disconnected, it avoids the retransmission. A slow start by just shrinking the sender's window size directly to 0 value. No buffering. Lost packets will be automatically retransmitted to the new supervisory host. But what are the disadvantages? SH does not act as a proxy. Loss on the wireless link, it propagated to the fixed network also. Another variation is the fast retransmit or fast recovery protocol. Change of foreign agent often results in packet loss. TCP reacts with a slow start, although there is no congestion. So forced fast retransmit is being done. As soon as the mobile host has registered with a new foreign agent, the MH sends duplicated acknowledgements on purpose. This forces the fast retransmit mode at the communication partners. Additionally, the TCP on the MH is forced to continue sending with the actual window size and not to go into slow start after registration. What are the advantages? Simple changes result in significant higher performance. Transmission, timeout freezing. This is another variation of the TCP protocol. Here the mobile host can be disconnected for a longer time. So no packet exchange is possible. Example, in a tunnel, disconnection due to overloaded cells or multiplexing with high priority traffic. These are some scenarios where no packet exchange is possible. TCP disconnects after timeout completely. So the TCP freezing need to be done. MAC layer is often able to detect interruption in advance. So MAC can inform TCP layer of upcoming loss of connection. TCP stops sending at that time. As soon as it receives that information, TCP will stop sending, but does now not assume a congested link. MAC layer signals again if reconnected. So this scheme is independent of data, but TCP on mobile host has to be changed. So the mechanism depends on the MAC layer, that is the communication between the TCP and the MAC layer is required. Another variation is selective retransmission, that is TCP acknowledgements are often cumulative. So if we say AKGEC, then what it means? It means it acknowledges correct and in sequence receipt of packets up to sequence number n. If single packets are missing quite often, a whole packet sequence beginning at the gap has to be retransmitted, that is go back and protocol being followed in this case, thus wasting the bandwidth. So selective retransmission is one of the solution in this case. RFC 2018 allows for acknowledgements of a single packet, not only the acknowledgements of in sequence packet streams without the gap. Sender can now retransmit only the missing packets. So it is having much higher efficiency, but disadvantage is it requires a more complex software as compared to other TCP variations. Another important protocol is transaction oriented TCP or the TTCP. TCP phases, what are the typical TCP phases are? Connection setup, data transmission and connection release. And how these connection setup is being done? It uses a three-way handshake which needs 3 packets for setup and release respectively. Thus even short message, that is if you are sending only 1 byte, it need a minimum of 7 packets. So in the case, what is happening in the transaction oriented TCP, that is RFC 1644 or the TTCP, it describes a TCP version to avoid this overhead. Connection setup, data transfer and connection release can be done with the help of only 2 or 3 packets. So the efficiency has been improved. How it is being done? As we are aware, this is my connection setup phase, this is data transmission phase, and this is my connection release phase. In the ordinary 3-way handshake protocol, what is happening during the connection setup? TCP SYN packet is being sent to the CN. It will send an acknowledgement, and TCP acknowledgement when the node it receives this packet TCP ACK packet, it will assume that the connection has been set up, and only after this the data is being set between the 2 parties. When the data is exchanged between sender and receiver, after exchanging the data, the connection is to be released, and again these packets is being exchanged between the 2 nodes. That is, it will send the TCP FIN packet to the CN, it will send ACK packet, that is okay, now it is also ready to go for the connection release, and once it has received the ACK, it will send the TCP ACK to the CN. Now the CN is aware that MN will no further send the packets to the CN and the connection has been released between the 2. Now what the TTCP has done, in the case of the TTCP, Along with TCP SYN, the MN is sending the data, but this data needs to be very short to the CN. Once the CN receives the data, it will send TCP ACK as well as FIN packet. Both the things are being included in one packet. And once the MN receives this, now it will assume that the packet has been successfully received by the CN and the connection need to be released. So in return, it will send TCP ACK packet to the CN. Now CN comes to know that there is no further connection between the two. So TTCP can combine the packets for connection establishment and connection release with user data packets. This can reduce the number of packets down to 2 instead of 7. The obvious advantage for certain application is the reduction in the overhead with standard TCP has for connection setup and connection release. This table is basically showing the comparison of different approaches for the mobile TCP, that is indirect TCP, snooping, M-TCP, fast transmit recovery, transmission, selective retransmission, transaction oriented, that is TTCP protocol. When we talk about the mechanism of the indirect TCP, it splits the TCP connection into two connections. In the case of the snooping TCP, it snoops the data and acknowledgements and the local retransmission is being done here. In the M-TCP, what we have seen that this it splits the TCP connection. It chokes the sender via window size, that is congestion window size is being used here. In the case of this, it avoids the slow start after roaming. This, it freezes the TCP state at disconnect, resumes after reconnection. In the case of the selective retransmission, it will retransmit only the lost data. In the TTCP, it combines connection setup, release and data transmission into one. What are the advantages? Isolation of wireless link. It is quite simple. In this case, transparent for end-to-end connection. MAC integration is possible in this case. It again maintains end-to-end semantics and handles the long-term and frequent disconnections. Fast retransmit protocol is simple and sufficient. In the case of timeout freezing protocol, independent of content or encryption, works for longer interrupts. Selective retransmission is again very efficient. And the TTCP, it is efficient for certain applications where the data is very short to be shared. But the disadvantage is loss of TCP semantics, higher latency at handover in this case, problematic with encryption, bad isolation of wireless link, again bad isolation of wireless link, in this case mixed layers, not transparent. In this case, changes in TCP is required because it is depending upon the MAC. Slightly more complex receiver software, more buffer is required in this case. Again, here we require the changes in the TCP protocol. These are the references being used for these slides. Thank you. So, in this, what we particularly discussed about the various variants of TCP protocol when we are communicating over the wireless link. Thank you and Jai Hind.